Let me start screen sharing now. So we're on page 133. We're going to continue to talk about solving systems of equations today. The difference will be that instead of just having those two equations given to us, we're actually going to write them based on the scenario that we have presented in our notes. Okay, so we're writing equations in addition to solving them by graphing today. Now we have written equations from context before. We did that in our last unit. We did that in unit 2. So that's not new. But the new part for today will be that our scenarios are actually going to give us information to write 2 equations. Okay, it's a system, so that should make sense. We're writing more than one. So let's go ahead and look at our first problem here. It says a used bookstore has started selling used CDs and videos. In the first week, the store sold 40 used CDs and videos at $4 per CD and $6 per video. The sales for both CDs and videos totaled $180. So we're going to write a system, we're going to graph it to find our solution, and then we'll give that solution. Okay. So if I look at my problem here, it gives me a couple different types of information. It tells me a total amount that I sold of just items between CDs and videos. And then it also gives me some price information. The price I sold CDs for, the price I sold videos for, and then the total that I made. That price information is kind of similar to a few examples that we looked at in our last unit. If you remember, we looked at that example problem when we started off standard form, where we talked about buying, I think it was like almonds and M&Ms in bulk, and we knew the prices of each thing per pound, and we knew the total that we spent. This is kind of similar to that. So I'm going to write that price equation first. So the other thing I'm going to notice is on my graph over here, my axes are labeled. CD is labeled on the x-axis, and video is labeled on the y-axis. So I'm going to use x and y since I already have these labeled axes. So 4x plus 6y equals 180. And then I'm going to define my variables down here, just so I'm kind of out of the way of my equations. I'm letting x represent the number of CDs sold. And I'm letting y represent the number of videos sold. So what I'm saying with this equation is $4 for every CD I sold. That would give me the total amount of money I made from CDs, plus $6 times however many videos I sold. That would give me the total amount I made from selling videos. If I add those amounts up, I get $180. That's what I'm saying there. So that's one equation. The other information I know is that I sold a total of 40 things. So that would be however many CDs I sold plus however many videos I sold should be a total of 40 things. That would be my second equation. Questions for me so far? Now I want to graph each of these equations on my coordinate plane over here. So I'm going to go ahead and change these to slope-intercept form to make them a little easier to graph. For my top equation, I'm going to move the x to the other side. So that would give me 6y equals negative 4x plus 180. And then to get y by itself, I have to divide each term by 6. So I get y equals, that would be negative 2/3 x plus 30 when I reduce. Now I can go ahead and graph this. My y-intercept is at 30. And then my slope is negative 2 over 3. So I'm going to go down 2 and over 3. Down 2 over 1, 2, 3. Down 2, 1, 2, 3. And 1, 2, 1, 2, 3. Make sure you guys can see that. Okay. And then my other equation, I'm also going to change to slope-intercept form. I'm going to move that x to the other side. So that would be y equals negative x plus 40. And then I'm going to graph that equation. So my y-intercept is 40. And then my slope is negative 1. So I'm going to go down 1 over 1. And then again, connect my points. So on my purple line, what I see are options that I have to sell $180 worth of things. So I would sell $180 worth of things if I sold no CDs, but 30 videos. Or if I sold 15 CDs and 20 videos, that would be a total sale of $180. So any point on this line represents how many CDs and videos I would need to sell to make $180. On my red line, that second line I drew, all of those points represent combinations of CDs and videos that I could sell to end up having sold 40 things. So I could sell 5 CDs and 35 videos. I could sell 40 CDs and no videos. Any point on that line would be amount of CDs and amount of videos I could sell to have a total of 40 things that I sold. What we want to know is what point on these lines meets both of those criteria. So that would be where they intersect, that point on both lines. So my solution here would be 30, 10. But today, since we have a context to all of our problems, I don't want to just give the ordered pair. I also want to describe what those values represent. So 30 represents the number of CDs we sold. So the store sold 30 CDs and 10 videos. Questions for me on example 1? Okay, let's take a look at example 2. Same idea for example 2. We're going to write our system of equations and then solve it with a graph. So number 2 says an office building has 2 elevators. One elevator starts out on the 4th floor, 35 feet above the ground, and is descending at a rate of 2.2 feet per second. The other elevator starts out at ground level and is rising at a rate of 1.7 feet per second. Write a system of equations to represent the situation. Solve using your graphing calculator. So this time we're going to create the graphs on our calculator. Now, as I look at the information I'm given here, I'm given for each elevator its starting height, as well as the rate that it either rises or falls. Okay, so that means I'm given the information I would need to write slope-intercept form for each of these. So I'm going to write an equation for each elevator this time. So for elevator 1, I start out 35 feet above the ground, and then I'm descending at a rate of 2.2 feet per second. So my equation I'm going to write here is y equals, since we're descending, that means we're going down. So negative 2.2 x plus 35, since it's my initial height. For this system, y is the height of my elevator. And I'm using x to represent the time that that elevator has been in motion. How long has it been going up or going down? If you want to use other letters and not x and y when you write your functions, that's fine. But then when we go to graph our functions on the calculator, I'm going to have to switch over my variables to x and y. So that's why I'm just writing them using x and y here. So I don't have to switch them later. So there's my first elevator. And then the other elevator, it says starts out at the ground level and then it's rising at a rate of 1.7 feet per second. So for elevator 2, I would have y equals 1.7x plus 0. If we start out on the ground, that'd be 0. Questions for me on those equations? Okay, so now I'm going to hop over to my calculator. Let me pull this up here. And I'm going to just go ahead and get rid of that, make a new document. I want this to have a graph because I need to graph stuff. And then I'm going to type in the equation for each graph. So for my first one, negative 2.2 x plus 35. Now, when I hit enter here, I didn't see the graph on my screen. I didn't see the graph on my screen because the y-intercept for this function is 35. And the biggest y I can see is 6 2/3. So we'll adjust our zoom here in a minute, but I want you to keep in mind that if you hit enter and you don't see anything, it does not mean that you need to panic. What it probably means is you have to adjust your zoom. So I'm going to graph my other function before I do that. So if I hit the tab key, it brings up that entry line again. And then I want you guys to notice that we see f2x equals here. That's your calculator's way of saying y. Okay, this is talking about what function we're looking at. So you don't need to type the y equals part. It's here for you. You type everything after the equal sign as you have it written on your paper. So for our second function, that would be 1.7x. If you want to type the plus 0, you can, but you can also leave it off here. And then I'm going to hit enter. So I see the graph of my other line. Now, what I'm looking for is where do these lines intersect? Right? That would be the time and place where our elevators are at the same height. So I need to adjust my zoom so that I can see that other graph. So I'm going to hit the menu key, and then I'm going to go to Windows Zoom. And if you can see that your intersection is going to be just off your screen, zoom out is a good option. But if you've got kind of no idea what that other graph is or where your intersection might be, then let's try Zoom Fit. That usually gives us a pretty good readjustment where I can see the interesting stuff that's happening. In this case, that intersection. I'm just going to go ahead and drag this over a little bit so I can see it a little better. Now, anytime we're using our calculators to graph, you do not, and you should not, guess. Your calculator can tell you exactly where intersections and x and y intercepts and minimums and maximums are. It can tell you exactly. You do not need to guess. So to get it to tell me where that intersection is, I'm going to hit the menu key and then go down to Analyze Graph. And we want to know where that intersection is, so I'm going to choose intersection from that menu. I get this sort of dashed line that pops up on my screen. So I want to click on either side of that intersection. Okay, so my intersection is in that sort of shaded region. And then I can see, I'm going to move this label here so I can see it a little more clearly. I can see that my point of intersection is 8.97, 15.3. So I'm going to jot that down on my paper. That 8.97, 15.3. And then I'm going to put this calculator away so I can take a look at my paper again. So here's that point of intersection. Unlike last time, I'm not just giving a point for my solution. I have to say what this represents. If our problem has a context, I need to give my answer with that context. So this means that our elevators are both at this height, because y is my height, at this time, because x was my time. So I'm going to write the elevators are both at a height of 15.3, looks like feet is the label we used for height, 15.3 feet after 8.97, and our time label is seconds. 8.97 seconds. Questions for me on number 2? Number 3, the same kind of idea. So for example 3, this says Olivia and her brother William had a bicycle race. Olivia rode at a speed of 20 feet per second, while William rode at a speed of 15 feet per second. To be fair, Olivia decided to give William a 150-foot head start. The race ended in a tie. How far away was the finish line from where Olivia started? So I have information about Olivia's speed and her starting position, as well as William's speed and his starting position. So that means I can write an equation to represent each of them. Okay? I'm going to start with William because I think his initial information is a little bit easier to think about putting into an equation. So for William, we know his speed and we know he got a 150-foot head start. So his equation would look like y equals 15x plus 150. He started 150 feet ahead of Olivia. So for my function, I'm using y to represent our distance, how far he's traveled. And then I'm using x to represent time, how long they've been racing. For Olivia, I know her speed is 20 feet per second, so that would be y equals 20x. But then she started at the starting line, right? William got a head start. She started at the starting line. So this would be like a +0 for her. For that +0, you can write it or not. Remember, when I add or subtract 0, that doesn't change my problem. So now that I have my equations, I'm going to go back to my calculator and graph. Let me pull my calculator up here. There's a bunch of different ways that you could delete the graphs from your page or create a new page. I'm going to go ahead and just modify the graphs that I have on here. So this 1.7x, I'm going to change to be 20x. That will be Olivia's line. And then I'm going to double click on my label here and I will change this equation to be William's line. So he was 15x plus 150. I can't see the blue line anymore. So again, I'm going to need to adjust my zoom, menu, window zoom, and I'm going to do zoom fit again. And now I can see that I should have an intersection out here somewhere. So you could zoom out, or it seems to me like it should be pretty close. So I'm going to drag my graph until I can see that intersection. And then just like I did before, menu, analyze graph, intersection, click on either side of where that point should be. And let's just move that label up there so we can see it. So 30, 600 is my point of intersection. I'm going to jot that down. 30, 600. And then let's put our graph away so we can see what we're looking at. So what I want to know is how far away was the finish line from where Olivia started? Well, that's the distance. Remember, she started at 0. So how far did she have to go? 600 until they tied, until they were at the same place. So the finish line was 600, and our distance label here would be feet, 600 feet away from Olivia's starting position. If they had asked me how long was the race, I would say 30 seconds. Any questions for me on number 3? Okay, on the next page. Number 4. I want you to try number 4. So write your system and then use your calculator to find where those lines intersect. So try number 4. So number 4 says 2 planes are in flight near a local airport. One plane is at an altitude of 100 meters and is ascending at a rate of 400 meters per minute. So I know an initial value and a rate for that first plane. So I can write an equation for that first plane. So for plane 1, I would have y equals, ascending means we're going up. So 400x plus 1,000. And then the second plane, let me define my variables. Y would be the height or the altitude of our plane. And then X would be our time. How long have I been ascending for this first plane? And then for my second plane, I again have an initial value. We have an altitude of 5,900 meters. And this one is descending at a rate of 300 meters per minute. So for plane 2, my function would be y equals, since we're descending, that means we're going down, negative 300x plus 5,900. So those would be my 2 functions. And then to figure out, are the planes ever at the same altitude? That's my question. So I want to know, are they ever at the same height? Okay. The only way they would not ever be at the same height at the same time is if my lines were parallel. I know that they're not parallel because their slopes are not the same. So I'm going to go ahead and figure out when they are at the same height and what that height is. So I'm going to bring up my calculator again. And then I'm going to go ahead and actually just get rid of this, make a new document, scrap that and start from scratch. So my first graph would be 400x plus 1,000. I get something really steep. Remember, your slope here is 400. That means we're going up 400 and over 1. So it's going to look pretty steep here, okay? We'll adjust that in a minute. And then tab key to get that equation line back up. This time I want negative 300x plus 5900. And that one I don't even see. That's okay. We'll see it when we adjust our zoom here in just a minute. So I'm going to hit menu. And then window zoom. And I'm going to do a zoom fit again. And there, I can see my intersection. Move this equation out of the way. And then menu, analyze graph, intersection, click on either side to see where that intersection is. How many people got this? 3.8e plus 3. Who got something like that on their calculator? A few of us. Okay. So your calculator, you're getting this because your calculator is set up to only give you so many digits. No matter how big the number is, it's only going to give you so many digits of it. So in this case, where we're going to have a really large number, it just flipped it to scientific notation here. So this means 3.8 times 10 to the third, if you remember scientific notation. So one option that you have is just to let your calculator give you scientific notation and then switch it yourself. So this would mean move my decimal point 3 places to the right. The other option, if you are not interested in doing conversions from scientific notation, is to adjust some settings on your calculator. So I'm going to hit the menu key, and then I'm going to go down to settings and display digits. This is what I want to change. I want to change that float to like, 9 is good. And then I've told my calculator, hey, you can give me more digits. That's okay. So now it's not giving me scientific notation anymore. So that intersection point is 7,3800. I'm going to jot that down on my paper. And then I'm going to put my calculator away. And let's talk about what this means. So 7,3800. Are these planes ever at the same altitude? Well, yes. We knew it was going to be yes because our slopes for our lines are different. So they are at the same altitude. They reach, I'm going to add in both. They both reach the altitude of 3,800, looks like meters as our distance label or altitude label. 1,800 meters after 7 minutes is our time label, minutes. Questions for me on example 4? Okay, try example 5. Example 5. We do need to be a little extra careful when we write our function for this problem, particularly for tree A. It says our tree A is 3 feet tall and grows at a rate of 18 inches per year. I'm not using the same unit here. I need everything to be in the same units, okay? And then for tree B, it says it starts off 4 feet tall and grows at a rate of 1 foot per year. So this inches is the odd one out. So I'm going to change it to feet. That would be 1.5 feet. 18 inches is 1.5 feet. You could also change everything to inches if you wanted to. The important thing is that we just be using the same units. So for my system, for tree A, I would have y equals 1.5x plus 3. Y is representing the height of my tree, and x is representing my time that the tree has been growing. And then for tree B, I would have y equals 1x plus 4. Now I'm going to jump back to my calculator. This time I'm just going to go ahead and reset on this page. So if I hit the delete key 3 times, it asks me if I want to get rid of all this stuff. I'm going to say yes. And then I'm also going to switch my zoom back to what it normally is. So if I go to Windows Zoom and go to Zoom Standard, that basically resets my graph for me. I'm going to hit the tab key so I can type my equations. So 1.5x plus 3, and then tab key again. That would be 1x plus 4 for my second equation. And I can see my intersection is right up here. So menu, analyze graph, intersection, click on either side, and then use that label so we can see it. So 2, 6. 2, 6. Jot that down on my paper. And then my question is, after how many years will the plants be the same height? The trees will be the same height after, my time is my x value, so after 2 years. That's my time label for my problem. The trees will be the same height after 2 years. Questions for me for today? Okay. So let me go ahead and